Today we are going to see about polyhydroxy alkonates. So this polyhydroxy alkonates is mainly produced by the action of microorganisms. So when you take the polyhydroxy alkonates, it is a type of reserve food material that is produced by the microorganism when they act on the sugars and lipids. Okay, so this polyhydroxy alkanate is considered as the main reserve food material, and it is produced in larger amounts during the fermentation process, and it gets accumulated during unbalanced growth condition when the microorganisms are exposed to unbalanced growth condition. So this is the introduction of polyhydroxy alkonates. So now we will see the industrial production of polyhydroxy alkonates. So when you take the properties of this polyhydroxy alkonates, it is more ductile, it is less elastic, and it is thermoplastic, and it is an elastometric material. And when you take the temperature at which it melts and when it gets hardened is 180 degree and 40 degree centigrade, and it has a biochemical compatibility. So when you take the industrial production of this polyhydroxy alkonates, it is produced by different kinds of microorganism: Cupravidus necator, then Bacillus subtilis, Alkaligen latus, Aeromonas hydrophila. So all these microorganisms are able to secrete this polyhydroxy alkonates. And how this polyhydroxy alkonates is produced is when you supplement all the essential nutrients in the microbiological media. So what are the primary nutrients that are required for the growth of this polyhydroxy alkonates are carbon sources, nitrogen source, then you have vitamins, then sulfur, phosphorus, and sodium chloride. So all these essential nutrients should be provided in the media. So this is the production of the polyhydroxy alkanates using microorganisms. So next we move on to the pathway of this polyhydroxy alkanates. So what are the different enzymes involved in production is beta ketothiolase, acetoacetyl CoA, and PHA synthase. So this is the pathway of this PHA production, where you have the sugar and a fatty acid pathway. So both kind of pathway occurs in the microbial cell, and there is a serological conversion of the sugar into PHA. And this pathway occurs in all the microbial cells, where you have the production of intermeric compounds, that is acetoacetyl CoA and S-hydroxyl butyl CoA, and finally it gets converted into polyhydroxy alkonate. So when you take the fatty acid pathway, you call it as beta oxidation pathway, where the acetyl CoA is getting converted into enoyl CoA, and enoyl CoA is getting converted into hydroxy acetyl CoA. Finally it is getting converted into PHA. So this is the pathway that occurs in all the microbial cells. So when this PHA is produced is during the that is a reduction of food materials it mainly produces. So next we move on to the properties of PHA. So what are the different properties of this PHA and why it is used in different kinds of applications is that it is having a thermoplastic material. So it can be molded into any type of plastic material, and it is able to resist high temperature, and then it can withstand a high temperature, and it is ductile. So you can just convert it into any type of molds or any type of material, and then even though when it is exposed to UV, it will be very stable, and it is soluble in halogenated solvents, for example chloroform, and it is a very good biodegradable compound. So all these are properties of PHA. So what all we have discussed is, we have discussed the pathway of the PHA production, then we have learnt about the production of the PHA in different kinds of microorganisms. So when you take all the different microorganisms, Bacillus subtilis is most widely used, and then you have to keep it in mind that there are different kinds of enzymes which are playing a major role in production of PHA. Okay, and this is the overall production of this polyhydroxy alkonates.